If a modern electric car suddenly materializes in the Roman Forum in 50 AD, its battery becomes the most precious resource on Earth. Inside, the digital dashboard flashes a critical 12%. Without a charging station, the sensors will soon go dark, the motors will lock, and the most sophisticated machine ever built becomes a 3-ton ornament of glass and steel. Rescuing the vehicle requires more than a basic understanding of physics. You have to find a way to plug a 21st century computer into the existing industrial backbone of the Roman Empire. You actually have space to drive. The Romans maintained a network of 53,000 miles of paved highways, linking provinces from Britain to North Africa. These roads are built on deep, multi-layered foundations of crushed rock and gravel, topped with tightly fitted polygonal basalt stones. Unlike modern reinforced concrete, which can crumble in decades as internal steel rebar corrodes, Roman concrete utilized volcanic ash and lime crusts. When cracks form, water dissolves these lime deposits, which then recrystallize to seal the gaps, a self-healing mechanism that allows their structures to last for millennia. However, these roads are a minefield for modern suspension. You're navigating deep grooves worn by centuries of rigid axle carts, and maneuvering around high raised stepping stones placed mid-street to keep pedestrians out of the mud. Navigating this chaotic ancient traffic is an energy drain your battery cannot sustain. By the time you find a safe place to stop, the car has reached 0%. You are now stranded in a world that won't see a standardized power grid for another 1,800 years. To wake the car up, you have to start with basic chemistry. The Baghdad battery proves the concept. An iron rod, a copper cylinder, and a jar of vinegar can produce a rudimentary electrical current through a process of galvanic corrosion. By stacking layers of zinc and copper separated by brine-soaked pads, the voltaic pile generates a sustained flow of electrons. But one jar produces less than a volt. Recharging the car requires wiring thousands of jars into a massive array just for a trickle charge. Chemical charging is a logistical dead end. To get enough power to move the car, you have to find a way to generate electricity through motion. The Romans already understood the foundations of this. They had observed the magnetic pole of lodestones and the static charge generated by rubbing amber. The engineering hurdle is the wire. While Roman jewelers can draw gold into fine strands, you need a blacksmith to do the same with copper, and then you have to insulate every inch with resin or silk to prevent the coils of your rotor from short-circuiting. For the mechanical drive, you can utilize Roman water mills. These massive proto-industrial structures already harness the kinetic energy of rivers to grind flour and saw stone at a massive scale. By mounting your handmade copper and lodestone dynamo directly to the drive shaft of a water wheel, you're converting the constant flow of the river into a rotational magnetic field. This setup provides the first sustained high-wattage current in history, giving the vehicle the surge it needs to begin the long process of recharging. The car has power, but the rough roads have likely snapped a suspension component. Ancient iron is often too brittle for high-stress automotive repairs, meaning you need a stronger alloy. You need to implement a primitive Bessemer process. By using water-powered bellows to force a high-pressure stream of air through molten iron, you can oxidize the excess carbon and control the metal's temperature. This yields high-quality steel. By integrating Roman expertise in furnace construction with your knowledge of thermal engineering, you've created a material strong enough to support the weight and torque of a modern machine. The Roman Empire already possessed the necessary ingredients for an industrial shift: specialized glassblowing, standardized mass production of pottery, and vast organized supply chains. In trying to keep one car alive, you forced these separate Roman specialties to converge, pairing their water power logistics with new breakthroughs in metallurgy and electromagnetism. The car itself isn't what changes the world. It forces the Romans to integrate their existing industrial foundation to solve the problems it presents, potentially sparking an industrial revolution nearly 2,000 years ahead of schedule.